Okay. I want to talk about slice notation because uh, historically, just a lot of there's been a lot of confusion about this, and it's frankly not as complicated as it might seem. Personally, I think that it's the more the Python notation that throws people off, but I'll try to tie it back to some basic notation that you've seen before, specifically with vectors and matrices, and that should help. So so for some background, if we have a vector, let's say A equals 5, 6, 7, 8. So this is some four-dimensional vector. And generally, sure, we can write this as a column vector. That's typically the default thing. But here I've written it as a list of numbers, and that's also standard. That's like the Axler's linear algebra done right notation. So I'm going to assume that we're okay with this notation. And you can see very clearly that A, even though I'm not using that vector notation, it is a vector. And in this case, because it contains 4 elements, it is a 4-dimensional vector. And then okay, so if we want to select an element of A, then we use an index. Okay. And in math, indexing starts at 1. So A sub 1 is 5, A sub 2 is 6, and the pattern there should be clear. But in programming, indexing starts at 0. So A, and then instead of a subscript like we do in math, we'll use square brackets. So A of 0 is 5, A of 1 is 6, and so on. So yeah, no matter what, and in particular in Python, we will use the index starting at 0. So the index is, it tells you which element of the array or the vector that you want to pick. And right, and then in programming, vectors are just written as arrays. Okay, so the 1D case, the flat case is very straightforward. You just have one index if you want to pick a specific number. And of course, if you want to figure out the index for which you have a particular number, that's a bit more, there's a lot of that depends on the context and what you want to do. So for now, we're just talking about how the index works. Okay, so it's very technical. So let's start with this case. In Python, we write the above vector as A equals np dot array 5, 6, 7, 8. Okay, and if you're already familiar with Python, you can you'll notice that the square brackets here in this context means a list. And all I'm doing is wrapping that list in the array function. And now we have a Python array saved to A. So again, to select single elements of A, we use the index notation A square brackets I, where I is defined or chosen by you as the user. So I don't know, let's say this is a code block, or maybe I'll use a different color. I'll use the markdown notation actually. So triple quotes, and then next slide, A equals np dot array. So anything in red, I'm gonna try to write it so that you can directly write it in Colab or whatever you're using. And it'll start, yeah, like it'll start with the triple quotes and end with triple quotes. Print A of 0. The output will be 5 because 0 is the index 0 element. And if you're like me, this is like, it's so simple that it seems silly. I totally get that. Like this is like, what is even the point of doing this? And unfortunately, the only way I know how to explain the importance of this is by just saying, okay, do you have any very, very specific questions about how this notation works? Because if you have any confusion at this step, things will only get worse. And then also, as specific as this seems, its importance will become obvious as we use more advanced notation, and as we move along in the course. But the point is that you can always select, like if you have a flat array in this context, right? It's just one list wrapped with the np.array command function. We have a means to select individual elements. And that's just generally a thing that in programming, that's what we need to do. We have a collection of things. And, if you have a bookshelf, you want to be able to reach for the book. If you have a library, you want to be able to quickly find the correct book that you want. And that's conceptually, that's really similar to what we're doing here. We're just, we're using an index to select specific items from, in this case, a very small library of not books, but numbers. But that's the point of all of this, is that we have a way to very quickly pull out the specific numbers or the elements that we need. And how we do that and all the contexts in which we do that, that'll become more relevant, or like a lot more obvious with time. Okay. And then so that's for individual, that's when we're selecting single elements. To select multiple elements, we use slice notation. And the indexing, okay, so this is where we see that colon. The indexing, when you see a colon, is slightly different from using a single number as an index. Okay, and here's how I think about it. So we have that array 5, 6, 7, 8. The irregular index directly corresponds to the numbers, right? The elements. So index 0, a square brackets 0 will give you 5, a square brackets 1 will give you 6, and so on. And then we have the slice index, which is different. These go in between the elements. Okay, so we use the regular index without colons and use the slice index with colons. So let's say, I'll just rewrite this for concreteness. And you literally should, if any of this is still, if you're having any trouble at any point, I mean, literally write out the code that I'm writing down, and run it, and just see for yourself. Just go through the motions. Okay. So a of 0 colon 2. Well, let's do print. And using slice notation, yeah, let me schematically draw that. So we have 5, 6, 7, 8. We start at index 0. Okay, because we have a colon, we start at index 0, and then we go up to index 2. And because we have a colon, we use that the slice index is between the elements. Okay, so these are the two elements that we return. And this should be so obvious, like you want to practice that this becomes so obvious that um, as exercises predict the output of A of 1, 2. Well, actually, I'll do a whole list of these guys. So A of 1, 2, A of 0, 3, A of 2. Yeah, that's right. And then 2 colon. Uh, this is everything to the right of 2. And here too, like I understand um, the potential confusion of like, well, we've seen notation where we use multiple colons. We've seen notation where we use commas and we mix colon and commas. We'll get to that. Yeah, we will absolutely get to that. But I want to look at this restricted case um, because those other cases at the moment don't matter. And I really want to I want each and every one of you to understand whenever a colon appears, the indexing is always between elements, just like I've shown here. So that's the key point of what I've written. And then all right, and then here A of colon 2, this is everything to the left of, yeah, slice index 2. So predict those outputs, how this connects to commas and additional colons. Um, we'll get to that. We'll get to that. But look at this as its own set of um, of exercises to work through. Like this is this is really important. And then also determine the correct slice notation for the outputs. Let's say, yeah, 5, 6, 7, 8. So what slice notation would you have to use to get that array 6, 7, 8? And this is only using only a single colon. Double colons, honestly, I might have confused. Might have been more confusing. We will typically not see that, actually. Um, yeah. And the double colon is usually to get to skip elements or to flip the array. But um, yeah, I think the comma is going to be the one that's, yeah, we'll get to that. Okay. All right, so this should be, so the idea, the ideal goal is for you to look at these and then look at the array and say, I know, like, this is the slice notation that I want. So just as an example, to get the output, let's say 5,6, I use 5,6, either 0, 2, or colon 2. They happen to give you the same thing. And which one you use is going to, it can come down to a stylistic choice, a personal preference. Sometimes you have to adjust the start and end points. But for this example, for this specific question, you happen to have two equivalent solutions. Okay, so that's single array indexing. We talked about that already. But what about higher dimensional arrays? So okay, that was a flat array. What I want to do now is look at a a two-dimensional array. So now two-D arrays, matrices, and we'll use, let's use B. Yeah, I'll just copy paste this as we go along. So B, okay, so let's start with matrices. So let's recall indexing for a matrix. Let's say B is equal to let's use slightly different numbers. Yeah. So I'm using these numbers because they're different from the indices, but also from the array that we used before. And I'm trying to keep this similar enough to potentially confuse you. And if you're confused, you got to use that. So I encourage you to use that confusion as a guide to resolve your confusion. Confusion is actually a really good sign. And I don't know how much that's emphasized these days, but I certainly value that confusion. But yeah, so if we have this matrix, B11 is 4, B12 is 5, B21 is 6, B22 is 7. Okay, because the first index is the row, second index is the column. And let's draw this like this. This is column 1, column 2. This is row 1, row 2. So I will assume that you're familiar with this notation. This is something that I think you just unfortunately just have to memorize. The first index is always the row. Second index is always the column. And columns, I think of them like, in like Greek or Roman architecture, you have those Ionian columns. The columns are like, this shape. They stand vertically, and then the rows are just the other thing. That's the nice thing about having to learn things that are, well, you have two things to learn, and one is mutually exclusive from the other. No, that's I don't know. That's my way of remembering what the which direction the columns go. So yeah, just make sure to bring yourself up to speed on this. Don't worry if it takes you a while. Like for me, it always takes me a while to catch up to things that maybe it made sense a while ago, maybe even more recently, but the time doesn't matter. It's just what matters is that you're resolving your confusion, and because like that's the important part. Feeling like you're not getting things quickly and feeling bad about it is, I don't know. I just found that to be really unhelpful. It's a lot better to think on my terms and make sense of things on my terms. Okay, so the indexing for a 2D array is the same, but the indices start at 0. So let's look at a bit of code here. B equals np dot array. And the way that this is done is it's in order of rows. So I do square brackets 4 comma 5 to select to create that first row, and then comma 6 7. This creates the second row. And if we do print b 0 comma 0, print b 0 comma 1, print b 1 comma 0, print b 1 comma 1. And this will return, or this will output. It'll be like new lines after each one. So it'll go 4, 5, 6, 7. That's another way I mean, that's how I remember what these things do. Is I go back to what I knew about matrices, and then use that same knowledge here. And if you're starting in a vacuum, play around with this. I mean, the details matter. So if this is confusing to you, just focus on the single case with a single column and only numbers. Okay. Let's not worry about colons for this example, and say, okay, I want to look at the output of b 1 comma like without looking at the outputs of this, predict like what is 0 comma 0. What is the output of that? Alternatively, just like kind of similar to the exercises I was suggesting here, if I look at this element, what are the indices of that element? And here I know this is the second row, so it's row index 1, and it's in the first column. So this often I often write this as np dot array 4 comma 5 comma new line 6 comma 7, like this, because this just visually looks like a matrix. And visually, then it's easier for me to tie it back to there. But here too, this is Here, let me just rewrite the thing. Okay, so like matrices, if we write B equals np dot array, four comma five, 6 comma 7. Okay, so this is going to be, now instead of column 1, this is column index 0, column index 1. And how we select columns, we'll have to use, we will use slice notation for this. And then, and same here too, we'll use slice notation. So this is row index 0, row index 1. Okay. And so that leads us naturally into the use of slice notation. And yeah, I understand arrays in general are going to be quite large, but if you can have take a leap of faith and trust that everything I say here is it actually generalizes really, really nicely to larger arrays and even multi-dimensional arrays, then it'll be worth the effort. It'll be worth your time and effort. Okay, so for slice notation, let's see, how should I start this? I mean, there's so many different ways to explain this that I don't want to make it sound like there's only one way to think of it. So I'll just do it by way of example. So, I mean, we saw above, yeah, so if we use a single index and a comma, then there's no, then we pick a single element. That's really it. And the way that it works is the same as matrices, meaning like the first index is always the row, second index is always the column. Now, now B, let's see. So B of colon comma 0, this is all rows, column index 0. And that is, so all rows, column index 0. It's this guy. If we do 1 colon 0, so first I encourage you to pause and just predict what this might look like. Even if you have zero idea what this might look like, just try it, because that taking that step into confusion is so important. So go ahead and guess. And I'll just go straight to the answer here. So this is all rows after the first. Okay, right? Because we're using a colon, now the notation, the index notation changes a little bit. And yeah, so 1 colon means all rows after the first. This is column index 0. And yeah, some of you are like me, and it's like it's so artificial. Like this is so specific, but just stick with me. And the payoff is going to come through the semester, right? It's not going to be like not necessarily going to be like right here, right now. And yes, it's potentially very boring, um, but I don't have a better way to teach this at the moment, and um, it's one of those things where I do have to ask you to just follow along. So yeah, so here all rows after the first. So this is the first row, or row index 0, but we skip that and then we end up here. That's the rows, and then the column index, it's just column index 0. We're looking at the first column, so it's that guy. Okay. And you don't have to explain this to yourself like I'm explaining it to you. Like, just figure out a way that it makes sense for you, no matter how silly it might seem. Let's do 1, comma 0. Okay, now there's no colon. Um, this is still the row index, or row index 1. Column index 0, row index 1, column index 0. It just happened to be the same thing as what I showed above. But again, I emphasize that the end result is it's not the most important thing. It's the process we're going through of deciphering what the notation here, how that, how to translate this notation into actually what the element of the array is. Okay, and let's say this, and again, try pausing and predict, no matter how confused or how little idea you might have of how to proceed. See if you can predict what's going on. And I'll show you the answer here. So this is all rows after the first. So the first row, I mean here, right? Row index 0 for the array. And all columns. Okay, so all rows after the first and all columns. And we will repeat this with a bigger matrix in a moment. Uh, yeah. right. For this next one, what about this? So go ahead and try and predict what that is. And I'll assume you're thinking about it. And if that you've unpaused, so I'll just give you the answer here. This is all rows. All columns before column index 1. And I realize I'm not being entirely consistent with how I'm describing this, but that's part of the point. There are just so many different ways of thinking, of just explaining this thing, and I think that's that's the point of me showing this concretely too, is that I will say these in a bunch of different ways, but I'm really talking about something very, like, a lot more straightforward. So here, all rows means, we're starting with all rows, then all columns before index 1. So it's this, yeah, that guy. So how does so it should start to become clearer with all these examples, just like how slice notation here, there's a very concrete way of explaining what slice notation looks like in that context. There's a very concrete way of understanding what regular indexing and slice indexing looks like with arrays. So it's very important that you clarify for that for yourself. And yeah, and you might ask, like, again, if you're like me, like, you might wonder, like, what if I want to select these two guys? And the way that we're learning slice indexing, we're not going to worry about that here. If you want to select those guys, yeah, you'll have to use like a mask or specific indices. But I'm discussing kind of the backwards direction and a very specific direction, and I understand how artificial this looks. But this is this is a struggle I've always had with math, of like, and programming, of like, wow, these methods seem so specific, like so specific that they might seem useless. But with time, I'll show you that they're actually not that specific. They're actually, well, they are specific, but they turn out to be really, really useful. So you'll have to take a leap of faith if you're new to this and having trouble seeing the importance of it. Believe in me that believes in you. It's from Gurren Lagann. Pretty good show. Okay, and then so exercise. Try or predict or write down the slice notation to obtain the elements, let's say, for 6, for 5, for 7, and do more. I mean, these are, like, if there's still confusion with this, you should use my my exercises here as a starting point. And yeah, I understand that it does take a lot of work. But I really, I mean, this is so important to drill that I'll go as far as to say that it's just, I don't know, it's just really important. And it's not always going to be obvious like why it's important or how it becomes important. It's just that, you know, if we're learning a new language like French or something, um, you know, at a certain point, someone's going to assume that you have a baseline understanding of the vocabulary and a bit of grammar. And this is the vocabulary and grammar portion of learning the language. So at some point, I'll just assume that you know it, and I'm going to just move forward assuming you know it. And that's why it's important, because if you don't take the time to practice your reps with this stuff, it's only gonna pull you, like, put you that much further back, right? So please, please make sure to understand this. And yeah. So for bigger arrays, let's say larger 2D arrays. Okay, let's just let little c equal np dot array. What number should I use? I'll do, yeah, I'll just start with 3, 4, 5, 6. 10, 11, 12, 13. 14, 15. I don't want to pick too big numbers because I'm lazy. So I'll just do 9, 8, 7, 6. Yeah. Okay, so for this guy, and for concreteness, I'll draw the I'll write the array next to what I'm showing you here. So let's say 1 colon, comma colon. So this is after the row index 0 and all columns. Okay. And if I was watching this 10 years ago and I saw someone quickly write out like that, I would be very discouraged. But I've just had a lot of practice with this. So the fact that I'm quick is not, you know, take time out of the equation of all of this. I'm just showing you the right answer for this, but you have to take the time to make sure this makes sense to you on your terms. Okay. Don't worry about how much time it takes. Don't let yourself feel bad or let others make you feel bad about taking too long or too short. Yeah, just for this stuff, be a little bit selfish. 0, comma, colon 1. That's row index 0, and then everything up to column index 1 exclusive. So yeah, I'm explaining a little bit less because the exact same things I discussed in the previous page, I'm putting those same things to practice. So if you're new to this, as I write down the slice notation on the left, feel free to pause the video. Like, in fact, I would say, like, you really should pause the video and predict what I'm going to circle. Um, let's see, 1, comma, 1 colon 2. So that's row index 1, and then column index 1 to 2. So it's that guy. I guess, yeah, so slice notation is a lot like, it's a lot like a rook, like in chess. You're only going to pick elements like going up and down, across. There's not going to be any like weird shit like, like a knight movement or something. There's no diagonal stuff. You can pick one element certainly. Um, yeah, so a lot like a rook. So a rook can move 2 places left and right. It can move like 3 places up and down. It can move 3 places up and left and right. So maybe that could be another helpful way of thinking about that, especially if we're working with 2D arrays like this. And then I'll do one more example. And again, use this as a starting point. As specific as this stuff I'm showing you is, getting good at this, recognizing this notation it'll help. It'll help a lot. And not just in this class, but just in general data science. MATLAB uses very, very similar slice notation. And it's a common language used by people that work with data. So yeah, super important to know. Okay, and then for this last example, let's see. Let's do row index 2 and 2 colon. So that's row index 2. This is index 0, row index 0, row index 1, row index 2. So we're looking at this row, and then columns. So that's column index, slice index 0, 1, 2. So those are the 2 elements. And then for practice, pick a random set of elements. And of course, random here being restricted to like up, down, left, right. And write down the slice notation. So let's see. So like, like pick a, here's an example, like here's an example, here's an example. Yeah, you get the idea, I think, by picking those 3 guys. Okay. Okay. So this slice notation, it generalizes. So if I have a bigger array, using this analogy with the rook, you can imagine with a much bigger array that I can select a bunch of rows, or a bunch of rows in a specific column, or a bunch of a couple of columns like that. So yeah, we'll see how much this helps. Just let me know if you have any questions about this. I guess that the takeaways are that what I'm showing you here is it's all about, it's very specific to slice notation and slice indexing and just slicing. And slicing itself, it can seem very artificial because, like again, like what if you want to select elements that are like diagonal like that? And for that, we will need different tools. So we've talked about that a little bit already in one of our more recent lectures, um, the point here is slice notation. And this is what slice notation looks like. This is what it does. And the more flexibility and speed you can pick up with how to go between the notation and the actual matrix, the better off you will be this semester. And I'll definitely test you on quizzes about this. But just to emphasize the context of this, it's the basic grammar of the things I'll be talking about. So the payoff is not going to be entirely obvious, but it's more like a lack of pain. Like you'll avoid more pain by doing this. I hope this helps. Again, let me know if you have any questions, and I'll see you later.